So I'm Hayden Kubishna, and this is my tech feature presentation on big data. I learned a lot researching this, and I hope you guys will too. So without further ado, we're going to jump into what exactly is big data. So you see these nice charts, you see some line graphs, some great stock images. This is not big data. Chances are this was like your sociology project that you surveyed 30 people and pretended like you did a good job, but you didn't. So this is a small amount of data points. It's the little leagues. The big data, which is huge amounts of data collected and aggregated by computers, represented by the server rack, is the big leagues here. To move on from that, it's the future. I chose this futuristic stock image to represent the fact that companies look at this as a huge opportunity for, well, not actually just companies, but governmental entities look at this as a way to increase efficiency and things like that. So anywhere from satellite images to online shopping ads to visualizing census data, all is functions performed by big data and analytics associated with that big data. So now there's 3 V's in characterizing big data: volume, velocity, and variety. And these are ways that you can look at how big data is being collected, how it's processed, and how it can be used. So volume, this is a normal hard drive, probably about 500 gigabytes to a terabyte. This would do nothing to hold any appreciable amount of big data. Big data comes generally in terabytes, petabytes, and exabytes, which are absolutely mind-bogglingly huge amounts. Velocity, this is how fast the data comes in and how fast it's processed. So that could be YouTube processing 300 hours of video in a second, or Amazon processing 400,000 customer requests in an hour. Variety is how easily quantifiable that data is. So whether it's just the binary likes or dislikes on Facebook, or something more like Kanye's Dragon Energy, I guess. But variety is one of the third V's. So there's also 3 secret V's that some data analytics experts think should be included. So veracity, how true it is; value, what its market value is; and viability, how it can be relied on to make predictions. And the fourth is for vendetta. Uses of big data. So Amazon, other large tech companies, so Amazon, Google, etc., all use big data to target ads at you, to target products at you, and that really is where the value part of the V's come in, because as market value. Now also there's other applications. So companies might use it with the Internet of Things to actually track how their trucks are going and how to optimize supply routes and things like that. Traders use it in algorithms, and Bitcoin traders use it to track social trends because it's such a volatile speculative market. Governments use it to transmit satellite images and also receive them. So NASA might use it to receive from their satellites, and public transportation uses it. Clearly, the MBTA does not do much to analyze it. So big data in the news. Cambridge Analytica, you might have heard of it, little thing, but they basically, for those who aren't familiar, they data mined a bunch of data from Facebook and used that to influence the 2016 elections. Mark Zuckerberg actually had to testify in front of Congress about this, and some experts are suggesting that there might be some governmental pushback against the use of big data, especially in social media. But the future of big data still remains bright. Companies are still really optimistic about the use of big data. People still think, as I previously mentioned, that it is going to be the future of many of these analytic projects. So let's look at a couple news stories. So increasing business integration, there's some articles run on Forbes about how you can better use the data that you have collected to optimize your businesses, whether that's with customers, with supply lines, etc. Also, medical applications. This one's a little more out of the box, but antibiotic resistant germs are kind of in the news as a piece of concern, and scientists can take a bunch of data, pour it into an algorithm, and actually sort it to see kind of what the most concern points are. And governmental and administrative, just as technology is making, for example, doing your taxes more accessible, big data is allowing governments to aggregate and use tax data in a way that they couldn't before and track it much better than before. This is my works cited. Any questions, compliments? Thank you.